Major functional components. DBMS_DataPump contains the API for high-speed export and import utilities for bulk data and metadata movement. Direct Path API, DPAPI, Oracle Database supports a Direct Path API interface that minimizes data conversion and parsing at both unload and load time. DBMS_metadata, used by worker processes for all metadata unloading and loading. Database object definitions are stored using XML rather than SQL. External Table API. With the Oracle_DataPump and Oracle_Loader access drivers, you can store data in external tables, that is, in platform-independent files. The select statement reads external tables as though they were stored in an Oracle database. SQL Loader has been integrated with external tables, providing automatic migration of loader control files to external table access parameters. EXPDP and IMPDP, thin layers that make calls to the DBMS_DataPump package to initiate and monitor data pump operations. Other clients. Applications, such as replication, transportable tablespaces, and user applications, that benefit from this infrastructure. SQL Plus may also be used as a client of DBMS_DataPump for simple status queries against ongoing operations. Oracle DataPump enables very high-speed data and metadata loading and unloading of Oracle databases. The DataPump infrastructure is callable via the DBMS_DataPump Place SQL package. Thus, custom data movement utilities can be built by using DataPump. Oracle Database provides the following tools: command line export and import clients called EXPDP and IMPDP, respectively. Export and import interface in Enterprise Manager Cloud Control. DataPump automatically decides the data access methods to use. These can be either direct path or external tables. DataPump uses direct path load and unload when a table's structure allows it and when maximum single-stream performance is desired. However, if there are clustered tables, referential integrity constraints, encrypted columns, or several other items, DataPump uses external tables rather than direct path to move the data. The ability to detach from and reattach to long-running jobs without affecting the job itself enables you to monitor jobs from multiple locations while they are running. All stopped DataPump jobs can be restarted without loss of data as long as the meta information remains undisturbed. It does not matter whether the job is stopped voluntarily or involuntarily due to a crash. The exclude, include, and content parameters are used for fine-grained object and data selection. You can specify the database version for objects to be moved, using the version parameter, to create a dump file set that is compatible with a previous release of Oracle database that supports DataPump. You can use the parallel parameter to specify the maximum number of threads of active execution servers operating on behalf of the export job. You can estimate how much space an export job would consume, without actually performing the export, by using the estimate_only parameter. Network mode enables you to export from a remote database directly to a dump file set. This can be done by using a database link to the source system. During import, you can change the target data file names, schemas, and tablespaces. In addition, you can specify a percentage of data to be sampled and unloaded from the source database when performing a DataPump export. This can be done by specifying the sample parameter. You can use the compression parameter to indicate whether the metadata should be compressed in the export dump file so that it consumes less disk space. If you compress the metadata, it is automatically uncompressed during import. Features of DataPump enable you to compress both data and metadata, only metadata, or no data during an export. Specify additional encryption options in the following areas. You can choose to encrypt both data and metadata, only metadata, no data, or only encrypted columns during an export. You can specify a particular encryption algorithm to use during an export. You can specify the type of security to use for performing encryption and decryption during an export. For example, perhaps the dump file set will be imported into a different or remote database and it must remain secure in transit. Or perhaps the dump file set will be imported on-site using the Oracle Encryption Wallet, but it may also need to be imported off-site where the Oracle Encryption Wallet is not available. Perform table mode exports and imports using the transportable method. Specify how partition tables should be handled during import operations. Overwrite existing dump files during an export operation. Rename tables during an import operation. Specify that a data load should proceed even if non-deferred constraint violations are encountered. This is valid only for import operations that use the external tables access method. Specify that XML type columns are to be exported in uncompressed CLOB format regardless of the XML type storage format that was defined for them. During an export, specify a remap function that takes as a source the original value of the designated column and returns a remapped value that will replace the original value in the dump file. Remap data as it is being imported into a new database. Use legacy mode to support the use of original export, express, and import, imp, scripts. Directory objects are logical structures that represent a physical directory on the server's file system. They contain the location of a specific operating system directory. This directory object name can be used in Enterprise Manager so that you do not need to hard-code directory path specifications. This provides greater flexibility for file management. Directory objects are owned by the SYS user. Directory names are unique across the database because all the directories are located in a single namespace, that is, SYS. Directory objects are required when you specify file locations for data pump because it accesses files on the server rather than on the client. In Enterprise Manager Cloud Control, select Schema, Database Objects, Directory Objects. To edit or delete a directory object, select the object and click the appropriate button. 1. On the Directory Objects page, click Create. 2. Enter the name of the directory object and the OS path to which it maps. OS directories should be created before they are used. You can test this by clicking Test File System. For the test, provide the host login credentials, the OS user who has privileges on this OS directory. 3. Permissions for directory objects are not the same as OS permissions on the physical directory on the server file system. You can manage user privileges on individual directory objects. This increases the level of security and gives you granular control over these objects. On the Privileges page, click Add to select the user to which you give read or write privileges, or both, read or write privileges, or both. 4. Click Show SQL to view the underlying statements. Click Return when finished. 5. Click OK to create the object. Data Pump Export is a utility for unloading data and metadata into a set of operating system files called dump file sets. Data Pump Import is used to load metadata and data stored in an export dump file set into a target system. The Data Pump API accesses its files on the server rather than on the client. These utilities can also be used to export from a remote database directly to a dump file set, or to load the target database directly from a source database with no intervening files. This is known as network mode. This mode is particularly useful to export data from a read-only source database. At the center of every data pump operation is the master table, MT, which is a table created in the schema of the user running the data pump job. The MT maintains all aspects of the job. The MT is built during a file-based export job and is written to the dump file set as the last step. Conversely, loading the MT into the current user's schema is the first step of a file-based import operation and is used to sequence the creation of all objects imported. Note: the MT is the key to Data Pump's restart capability in the event of a planned or unplanned stopping of the job. The MT is dropped when the Data Pump job finishes normally. You can interact with Data Pump export and import by using one of the following interfaces. Command line interface enables you to specify most of the export parameters directly on the command line. Parameter file interface enables you to specify all command line parameters in a parameter file. The only exception is the PARFILE parameter. Interactive command interface stops logging to the terminal and displays the export or import prompts, where you can enter various commands. This mode is enabled by pressing Ctrl+C during an export operation that is started with the command line interface or the parameter file interface. Interactive command mode is also enabled when you attach to an executing or stop job. GUI interface. Select Schema, Database Export, Import. In the menu, select the export or import operation you want to execute. Data Pump Export and Import provide different modes for unloading and loading different portions of the database. The mode is specified on the command line by using the appropriate parameter. The available modes are listed in the slide and are the same as in the original export and import utilities. Enterprise Manager Cloud Control provides a wizard to guide you through the process of performing a data pump export and import procedure. The example in the slide shows a data pump export. From the database homepage, expand the Schema menu, select Database Export, Import, and then select Export to export files to begin a data pump export session. The next window that appears enables the selection of export type. If a privileged user is connected to the database instance, the export types include the following: database, schemas, tables, tablespace, If a non-administrative account is used, the export type list is limited to the following: schemas, tables. Click Continue to proceed with the export. Oracle Database also includes data pump command line clients for import and export operations. The example in the slide illustrates a data pump import using the IMPDP utility. There are some parameters that are available only by using the command line interface. For a complete list of options, refer to Oracle Database Utilities. Because object metadata is stored as XML in the dump file set, it is easy to apply transformations when DDL is being formed during import. Data pump import supports several transformations. Remap_datafile is useful when moving databases across platforms that have different file system semantics. Remap_tablespace enables objects to be moved from one tablespace to another. Remap_schema provides the old FROMUSER/TOUSER capability to change object ownership. Remap_table provides the ability to rename entire tables. Remap_data provides the ability to remap data as it is being inserted. You can use the Enterprise Manager Graphical User Interface (GUI) to monitor all data pump jobs, including those created by using the EXPDP or IMPDP command line interfaces or by using the DBMS_datapump package. You can view the current status of the job and change the status to execute, stop, or suspend. To access the Export and Import Jobs page, select View Export and Import Jobs in the Database Export/Import menu. SQL Loader loads data from external files into tables of an Oracle database. It has a powerful data parsing engine that puts little limitation on the format of the data in the data file. SQL Loader uses the following files: input data files. SQL Loader reads data from one or more files, or operating system equivalents of files, that are specified in the control file. From SQL Loader's perspective, the data in the data file is organized as records. A particular data file can be in fixed record format, variable record format, or stream record format. The record format can be specified in the control file with the infile parameter. If no record format is specified, the default is stream record format. Control file. The control file is a text file that is written in a language that SQL Loader understands. The control file indicates to SQL Loader where to find the data, how to parse and interpret the data, where to insert the data, and so on. Although not precisely defined, a control file can be said to have 3 sections. The first section contains such session-wide information as the following: global options, such as the input data file name and records to be skipped. In-file clauses to specify where the input data is located. Data to be loaded. The second section consists of one or more into table blocks. Each of these blocks contains information about the table, such as the table name and the columns of the table, into which the data is to be loaded. The third section is optional and, if present, contains input data. Log file. When SQL Loader begins execution, it creates a log file. If it cannot create a log file, execution terminates. The log file contains a detailed summary of the load, including a description of any errors that occurred during the load. BAD file. The BAD file contains records that are rejected, either by SQL Loader or by the Oracle database. Data file records are rejected by SQL Loader when the input format is invalid. After a data file record is accepted for processing by SQL Loader, it is sent to the Oracle database for insertion into a table as a row. If the Oracle database determines that the row is valid, the row is inserted into the table. If the row is determined to be invalid, the record is rejected and SQL Loader puts it in the BAD file. Discard file. This file is created only when it is needed and only if you have specified that a discard file should be enabled. The discard file contains records that are filtered out of the load because they do not match any record selection criteria specified in the control file. The SQL Loader control file is a text file that contains data definition language, DDL, instructions. DDL is used to control the following aspects of a SQL Loader session: where SQL Loader finds the data to load, how SQL Loader expects that data to be formatted, how SQL Loader is being configured, including memory management, selection and rejection criteria, interrupted load handling, and so on, as it loads the data, how SQL Loader manipulates the data being loaded. The explanation of this sample control file, by line numbers, is as follows. 1. Comments can appear anywhere in the command section of the file, but they must not appear in the data. Precede any comment with 2 hyphens. All text to the right of the double hyphen is ignored until the end of the line. 2. The load data statement indicates to SQL Loader that this is the beginning of a new data load. If you are continuing a load that has been interrupted in progress, use the continue load data statement. 3. The infile keyword specifies the name of a data file containing data that you want to load. 4. The BADFILE keyword specifies the name of a file into which rejected records are placed. 5. The DISCARDFILE keyword specifies the name of a file into which discarded records are placed. 6. The append keyword is one of the options that you can use when loading data into a table that is not empty. To load data into a table that is empty, use the insert keyword. 7. The into table keyword enables you to identify tables, fields, and data types. It defines the relationship between records in the data file and tables in the database. 8. The when clause specifies one or more field conditions that each record must match before SQL Loader loads the data. In this example, SQL Loader loads the record only if the 57th character is a decimal point. That decimal point delimits dollars and cents in the field and causes records to be rejected if SAL has no value. 9. The trailing NULLCOLS clause prompts SQL Loader to treat any relatively positioned columns that are not present in the record as null columns. 10. The remainder of the control file contains the field list, which provides information about column formats in the table that is being loaded. Direct path loads use data saves to write blocks of data to Oracle data files. This is why the direct path loads are faster than the conventional ones. The following features differentiate a data save from commit. During a data save, only full database blocks are written to the database. The blocks are written after the high watermark, HWM, of the table. After a data save, the HWM is moved. Internal resources are not released after a data save. A data save does not end the transaction. Indexes are not updated at each data save. You can load data by using Enterprise Manager Cloud Control. In the Schema menu, select Database Export, Import. Then select Load Data from User Files. On the first page you indicate whether you are using an existing control file or want a new. On the first page you indicate whether you are using an existing control file or want a new control file to be generated. Click Continue on this page to invoke the wizard. If you activate SQL Loader Express mode, specifying only the username and the table parameter, it uses default settings for several other parameters. You can override most of the defaults by specifying additional parameters on the command line. SQL Loader Express mode generates two files. The names of the log files come from the name of the table, by default. A log file that includes the control file output, a SQL script for creating the external table and performing the load using a SQL insert as select statement. Neither the control file nor the SQL script are used by SQL Loader Express mode. They are made available to you in case you want to use them as a starting point to perform operations using regular SQL Loader or standalone external tables. A log file similar to a SQL Loader log file that describes the result of the operation. The %p represents the process ID of the SQL Loader process. The following is an example of the input data file named test.dat containing two records to load and excerpts of the two log files generated after the load completed. The table Our Test was created with three columns, C1 number, C2 VARCHAR2, 10, and C3 VARCHAR2, 10. An external table does not describe any data that is stored in the database. Nor does it describe how data is stored in the external source. Instead, it describes how the external table layer must present the data to the server. It is the responsibility of the access driver and the external table layer to do the necessary transformations required on the data in the external file so that it matches the external table definite file so that it matches the external table definition. External tables are read-only, therefore no external tables are read-only, therefore no DML operations are possible, and no index can be created on them. There are two access drivers used with external tables. The Oracle_Loader access driver can be used only to read table data from an external table and load it into the database. It uses text files as the data source. The Oracle_Datapump access driver can both load table data from an external file into the database and also unload data from the database into an external file. It uses binary files as the external files. The binary files have the same format as the files used by the Datapump import and export utilities and can be interchanged with them. The data files created for the external table can be moved and used as the data files for another external table in the same database or different database. External data can be queried and joined directly in parallel to tables residing in the database, without requiring the data to be loaded first. You can choose to have your applications directly access external tables with the select command, or you can choose to have data loaded first into a target database. The results of a complex query can be unloaded to an external file using the Oracle_DataPump Access driver. Data files that are populated by different external tables can all be specified in the location clause of another external table. This provides an easy way of aggregating data from multiple sources. The only restriction is that the metadata for all the external tables must be exactly the same. The metadata for an external table is created using the SQL language in the database. The Oracle_Loader access driver uses the SQL loader syntax to define the external table. This command does not create the external text files. The example in the slide shows three directory objects, xtab_dat_dir, xtab_bad_dir, and xtab_log_dir, that are created and mapped to existing OS directories to which the user is granted access. When the xtab_employees table is accessed, SQL loader functionality is used to load the table, and at that instance the log file and bad file are created. This example shows you how the external table population operation can help to export a selective set of records resulting from the join of the employees and departments tables. Because the external table can be large, you can use a parallel populate operation to unload your data to an external table. As opposed to a parallel query from an external table, the degree of parallelism of a parallel populate operation is constrained by the number of concurrent files that can be written to by the access driver. There is never more than one parallel execution server writing into one file at a particular point in time. External tables are queried just like internal database tables. The first example illustrates querying an external table named xtab_employees and only displaying the results. The results are not stored in the database. The second example shows the joining of an internal table named departments with an external table named xtab_employees and only displaying the results. The third example in the slide illustrates the direct appending of an internal table data with the query and load of data from an external table. The data dictionary views in the slide provide information about external tables, DBA, all, user, _external_ tables, specific attributes of external tables in the database. DBA, all, user, _external_ locations, data sources for external tables. DBA, all, user, _tables, descriptions of the relational tables in the database. DBA, all, user, _tab_ columns, descriptions of the columns of tables, views, and clusters in the database. DBA, all, _directories, descriptions of the directory objects in the database.